Alright, this is Module 22. We have circumference and arc length. First thing we need to introduce is the circumference. Circumference of a circle is the distance around the circle. This is something you have had in middle school, so you should recognize this. And basically the dashed line or the dotted line is going to represent your circumference of the circle. The other thing we're going to talk about is something called arc length. An arc length is the portion of a circle, or of an actual circle, but a portion of the circumference of the circle. So you got to think of it, if the entire circle or the circumference is the crust of a pizza, think of it as like a pizza slice, part of the pizza crust of a pizza slice. So again, what we had in previous modules, we were figuring out what arc angle measurements were, or what the actual degree measurements were. Now we're going to actually figure out what the actual lengths of those arcs are going to be. So a couple formulas that you need to know. Circumference of a circle, you've seen this before, so I'm just going to kind of rush through this. We have circumference is equal to either 2 times pi times the radius, and you can either use pi as 3.14 or you can plug it in as pi into your calculator. It's completely up to you. The other way you can also do it is circumference is equal to pi times the diameter, because 2 times the radius gives you your diameter, d. So, yeah, and that's basically what you've had in middle school. So, first example, we have find the radius of a circle with a circumference of 26 meters. So we have circumference is equal to 2 pi r. We know the circumference is 26 equals 2 times pi times the radius. In order to solve, you can divide by 2 pi, and you get around 4.14. Depending on if you used either the pi button in your calculator or 3.14, you'll get something that's around 4.14 in terms of the radius. Another thing you have to make sure of when you're doing this, don't forget your units. So we have meters, so we say 4.14 meters. Okay, tire revolutions, example 2, it says the dimensions of a car tire are shown at the right. To the nearest foot, how far does the tire travel when it makes 15 revolutions? So what we need to do is we need to figure out the circumference of the tire. So if we figure out the circumference of the tire, what I see is all the stuff that's labeled is 5.5 inches, 15 inches, and then 5.5 inches, because you have the actual tire width as well, and the rim width. So when you add those together, you get 26 inches is your diameter. So if we have 26 inches as your diameter, what you do is you multiply, set it into the circumference formula. So we know circumference is equal to 26, which is my diameter, times pi. And you can do that in the calculator. And once you do that in the calculator, you multiply straight through and through, and you should get roughly around 81.68 here. The reason you have to multiply it by 15 is because you have 15 revolutions. So every time that your tire turns, so if this is your point on your tire, if you are rotating, it's going to hit this point. That's one revolution, covers 81.68 inches. If you're trying to find out by 15 revolutions, you need to multiply it by 15, which gives you roughly about 1225.2 inches. In the question, what it is asking, it's asking to the nearest foot. So since we have 1225.2 inches, what we have to do is we have to convert that to feet. And there's 12 inches in a foot, so we would do a conversion and we get about 102.1 feet. Okay, in arc length, here's your arc length corollary. And remember, corollary is something that's easily proven using the original theorem, which is actually the circumference theorem. So we have, in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. It's a ratio, it's a proportion, which you actually have done in a previous module. So here's your actual formula. You can say the arc length, the actual arc length of AB in this case, which is the dotted line, you would take your central angle measurement, this is your central angle measurement, divided by 360, and you multiply it times your circumference, c. And that will give you, and in some cases, what you will have is you'll have the arc length, and it will ask to find your radius. You might have the arc length, you have your radius, and it might ask you to find the central angle. So there's many different things that I can ask, but the three things that you will need to plug in is your length of it, which is the AB, your central angle, which is the measure, that's going to be in degrees, and then your circumference, which depends on either the radius or the diameter. So here's your first one. So it says find the length of each red arc. So I have arc AB. So in this, I'm trying to find arc AB's measure. So I know my central angle is 60 degrees. Divide that by 360, and you times that by the circumference, which is 2 pi times your radius, which is 8. When you plug this into a calculator, you should get roughly about 8.38 centimeters. And again, it's centimeters because we're not talking about area. In the next module, we will be talking about area, and it will be units squared. But in this case, just centimeters. Okay, same deal here, just to kind of make sure you got the concept. So go ahead and work this out in your notes. Pause the video and see if you get it right. So if you worked it out, your arc length of GH, again, is 120 degrees, which is your central angle, divided by 360, times the circumference, 2 pi times 11, should be 11. And when you do that, you should get roughly about 23.04 centimeters. Okay, so the previous two examples were basically just to get you comfortable with the formula. Now, I'm going to start asking certain things about the formula, and you're going to have to solve them algebraically. So it says now, find the circumference C of circle with center Z. So in the formula, what I know, XY's arc length, that's 4.19. That's the first part of the formula. That equals your central angle. Central angle in this case is 40. Divided by 360, that's part of the formula, times the circumference. Now you could put 2 pi r, and if you did that, you'd be solving for r, and then you'd have to plug it back into your circumference formula to figure out what circumference is. Me, I'm going to simplify it completely and just say C is my unknown length or measurement. So when you do this, when you cross multiply, you can cross multiply or multiply by the reciprocal. When you actually reduce this, you get 4.19 equals 1/9 times C. And you can multiply by 9 on both sides to get rid of the fraction. And you get 37.71 inches. And again, that's circumference, so it's not units squared. And you're done. Okay? Use the previous example to see if you can kind of figure out and do this one on your own. You can pause the video now if you'd like. So we're trying to find out the measure of RS. Again, so we're trying to find this guy here, the actual degree measure, which means we need to find the central angle. That's why you have M here. So we're trying to find this. We don't know what that is. So plugging it into the formula, we know our arc length. We don't know our central angle, so we can call it X or some unknown. And we know our radius. So the solution would be you plug it into the formula. So we have the arc length of RS, which we know. So we know this one. We can figure out this one because we know the radius. We don't know this one, so we can call that our unknown. So we basically plug in everything that we know. So when you plug in everything that you know, 44 is what you know as your arc length. That's one. Your radius here is 15.28. plug it into the 2 pi r, evaluate this first, and then once you do that, you can cross multiply and solve. Cross multiply and solve. When you do that, you get about 165 degrees for the central angle. So one of the things that I'm sure people are asking, you have the formula that I gave you, arc length of RS equals, this is what I gave you in notes, the measure of RS over 360, and you times that by your circumference 2 pi r. Where this formula comes in is all I'm doing is I'm dividing by 2 pi r. I'm dividing by this value on both sides. So I'm basically just manipulating algebraically the formula that I was given. And I'm allowed to do that because it's an Algebra 1 tactic that you can use.